So this is lesson 8.4, and we'll call it A, elementary algebra, multiplication of radicals. All right, a couple things about the multiplication of radicals. I think they're a lot easier than doing the addition and subtraction. So we're just going to get started here with them. A couple things that you learn about the property of multiplication of radicals is if you take a square root and multiply, well, let's find one that changes here. Let's do square root of 3 times the square root of 2. What does that mean? It means all we have to do is take this times this. You can multiply anything in a radical and get that. Okay, so it looks easy enough. Now let's take something like this and still do the same thing. Okay, square root of 28. Now what you have to do is when you get the answer, you have to simplify it. So it's just like when you get a fraction like 2/4, you have to simplify it to 1/2. And that's the same thing that we're going to do with these. Once we get our radical, we have to see if we can simplify it. So what am I looking for? And let's review this. First thing you're going to do is there a square root of 28? Is there a number that when we square it, we get 28? No. Second part is, can we look at this, find two numbers multiplied together to give us 28, where I can take the square root of one of them? And let's try 14 times 2. Nope, there's not a square root of that or that, even though they multiply to give me 28. How about 7 times 4? Yes, there is. So we can write the square root of 28 as 7 times 4. What's the square root of 4? 2. With the square root of 7, we can't take the square root of that, so we just take the square root of 4, and we simplify by getting that. Alright, so let's keep going here. Okay, so to multiply something like an example 2, we multiply the numbers outside of the radical, then we multiply the numbers inside the radical and get our answer. And once we do that, we look and say, do we have a square root of 35? No, there's not. Are there two numbers multiplied together that give me 35, where I can take one of them and take the square root? No, there's not. Are there any other factors of 35? 7 times 5, those are both prime numbers. They can't be broken down. And so no, there's not. So that is as simplified as you can go. As long as you answered those questions and simplified it how you can, then you're good to go. So let's look at example 3. Example 3 gives us a square root of 5. Now remember, with the multiplication, you can multiply anything. So you just kind of ignore the radical and do everything like you normally do. Just drag the radical along with you. So what we're going to do is we're going to distribute 5 times 2, distribute 5 times 5. Okay? Now, can I reduce that? Square root of 10. Are there two numbers multiplied together where I can take the square root? All I have are 5 and 2, so no. So that can't be reduced. Can square root of 25 be reduced? Yes, it can. And we're done. Because we can't combine the square root of 10 and the 5, because we'd be adding. All right, so going to jump into another part here, and this is called the power property for radicals. This ends up being very, very important eventually. And the way this is going to, well, let's just put on an example. The square root of 11, and if that quantity is squared. Okay, so there is an index right there of 2. If this number and this number are the same, then all of this cancels out, and you end up with that as an answer. So if I have the cubed root of -6 and it's cubed, this, and the sign all disappear. Okay? So it's kind of an easy way to get rid of complicated stuff because it all goes away. Okay, so it makes it kind of nice. Alright, let's look at example 8 as we start practicing that. And again, I know there's tons of stuff here for you to remember. That's why you're taking notes, so that you have it to refer back to, because with the summer going so fast, I can't expect you to just memorize everything. Alright, so what we're going to do is we are going to distribute. So 3 square root of 2 times 2 square root of 5. 3 times 2 is 6. Square root of 2 times square root of 5. Square root of 10. 3 times square root of 2 times 5 square root of 6. 3 times 5 is 15. Square root of 2 times square root of 6 is 12. Okay. Square root of 10 cannot be simplified, so it just stays the way it is. And square root of 12. Are there two numbers multiplied together that give me 12 that I can take the square root of 1? Yes, so I could write the square root of 12 as the square root of 4 times 3, take the square root of 4, and move that out, so 2. So the square root of 12 is 2 square root of 3. Now we can multiply the 15 times the 2, and because this is a plus sign, that's a 10, and that's a 3, we can't combine. So that ends up being our answer right there. Okay, let's look at example number 9. Oops, not a square root, just 2. And square root of 5 plus 7. Notice we have two binomials, and in order to combine those, we do the FOIL method. FOIL method is first. Okay, the first one would be square root of 5 times square root of 5. Outside, square root of 5 times 7. Okay, inside, 2 square root of 5. And last. Okay, can I combine anything? Remember to combine. The radicand has to be the same, which it is, and the index has to be the same, which it is. So I can add these two. Oh, and the square root of 25 is 5. So let's see, we've got 7 and 2 is 9 square root of 5 plus 14. I can add that and that. So I get 19 plus 9 square root of 5. And that's usually how you write it, is the number first. I don't think it really matters. But anyway, let's look at example number 10 here. Number 10 is pretty much the same thing as what we just did. We're going to use the square root of x plus 3 times square root of x minus 7. Okay, so f first. Square root of x times the square root of x. Okay, this is where it gets like, what do I do with that? Well, what if I had x times x? What do I get? X squared. Okay, so I get the same thing here. Square root of x times the square root of x is the square root of x squared. And outside, this times this, negative 7 square root of x. Inside would be this, plus 3 square root of x. Whoops, that's not an x. And then last is 3 times negative 7. Alright, now remember from earlier I said if we have the square root of a number in squared, all of this stuff goes away and we just get 11. Same is true here. We have a 2 here and a 2 here, so everything goes away except the x. Negative 7 plus 3, and we get that. Okay? So this is example 11, and what we're doing is we're just multiplying this times itself. So it's square root of 3 minus 2, square root of 3 minus 2. So we do the FOIL. So we'll do first, square root of 3 squared, outside, inside, that times that last. And we can combine what we can. This here is just 3 because the radical comes off because of the squared part. Negative 2 minus 2 is negative 4 square root of 3. We can combine those because those are the same. Now I can combine that with that, so I get 7 minus 4 square root of 3. Okay, so let's go ahead and do one more on this video. We'll do example number 12. Number 12 is very, very similar to what we just did. It's square root of 6 plus the square root of 3, quantity squared. Okay, so let's write this as two binomials. Alright, so first, okay, so we can write it that way, or we can write it as the square root of 6 squared. Doesn't matter. Okay, let's write it this way for right now. Square root of 6 squared. Alright, then we do the outside. Just multiply inside. And then outside, or last, square root of 3 times square root of 3. And let's write that as just squared. Okay, so what do we get? 6. These two added together give me 2 square root of 18 plus 3, because remember all this comes off. Alright, now let's look here. We can reduce that because two numbers multiplied together give me 18, where one of them I can take a square root. So 6 times 3 is 18, but 9 times 2 I can take the square root of 9. So I get 6 plus 2 square root of 9 times 2. Take the square root of 9. And the square root of 2 stays in there. So 6 plus 6 square root of 2 plus 3. And then this and this give me 9 plus 6 square root of 2. And I'm done. Okay, so that's it up through example 12. So next video we'll start with 13.